Welcome, and thank you for joining us for the Supermarket News webinar, Understanding the Impact of California Refrigerant Regulations for Existing Food Retailers, with our sponsor and presenter, Chemours. I'm Mike Brown, Executive Editor of Supermarket News. Today, experts from Chemours are on hand to talk about the new California Air Resources Board, or CARB, regulations going into effect soon. During this session, we'll walk retail food operators through what this means for their existing refrigeration systems containing greater than 50 pounds of refrigerant. To assist supermarkets with refrigerant transitions, Chemours will be sharing a new tool to track the greenhouse gas potential and average GWP of their entire refrigeration footprint, so end users can model and calculate the impact of various refrigerant changes needed to achieve California regulatory compliance. Just a note before we begin, there will be a question and answer period at the end of the presentations. So if you have any questions, please feel free to enter those into the Q&A chat field on your screen. Also, note that today's webinar is being recorded and will be available on demand. You will be alerted via email when that archive is posted. If at any time you experience difficulties with the audio or advancing the slides, please refresh your console. With that, I'd like to introduce our speakers for today's webinar. Dr. Chuck Allgood is Technology Leader Refrigerants with Chemours Fluoro Products in Wilmington, Delaware. Welcome, Chuck. We also have Andrew Pansula, Technical Service Engineer for the Chemours Refrigerants team. Thanks for joining us, Andrew. And finally, we have Christina Spalding, National Account Manager for Chemours Refrigerant, who will be kicking off our conversation. Christina?
Thank you. Thank you for that introduction, Michael, and welcome everybody to our webinar today. Again, just to reiterate, the topics we're going to talk about today are the impact of California refrigerant regulations for existing food retail facilities. Brief overview of the agenda. I'm going to just do a brief introduction to Chemours, and obviously we've just learned who our presenters are. Spend a little bit of time talking about the regulations in California, and then move into refrigerant collection and HFOs and refrigeration as a path towards compliance for existing food retail facilities. And then we're going to spend some time sharing a new tool that we've developed that helps retail food end users create a pathway to compliance and scenario plan for California's upcoming regulations. Okay, very briefly, we just went through the introductions. Again, I'm Christina Spalding. Andrew Pansula and Chuck Allgood are both part of our technical organization, and they will also be presenters and panelists with me today as well. So very briefly, if you are familiar with Chemours, or if you're not familiar with Chemours, we spun off from DuPont in 2015. We are a global company headquartered in Wilmington, Delaware. We have about 7,000 employees worldwide. We are the inventors of Freon. We've been manufacturing refrigerants used in retail food refrigeration for well over 80 years. Freon is our legacy brand of HFC refrigerants. And we are also the inventors of our Opteon refrigerant solutions. These are low global warming potential, low GWP solutions that replace incumbent refrigerants like HFCs that are being regulated in California. All right, I'm going to spend a little bit of time talking about the regulations in California, and I do appreciate everybody who's participating in the webinar, inputting your familiarity with regulations. Most of the folks that are participating today have kind of classified themselves as somewhat familiar or very familiar, but I think it's important that we just start with a fundamental understanding of the regulations, and then I will talk specifically about the retail food regulation for existing facilities. So there's really two different environmental challenges that are driving industry transition today. One is ozone depletion. If you've been working in commercial refrigeration for the past several years, you're very aware of the Montreal Protocol. The Montreal Protocol was signed back in 1985, or mid-80s rather. And it is a global agreement of which the U.S. has ratified to phase out completely ozone-depleting products like chlorinated refrigerants. So CFCs, chlorofluorocarbons, HCFCs, hydrochlorofluorocarbons. That is done. That's a phase out. We're no longer producing these materials. There's no longer virgin product produced or imported. The products that were designed to replace these chlorinated refrigerants are HFC refrigerants or hydrofluorocarbons. They have inherent global warming potential associated with them, and global warming potential is the potential for a gas to trap heat in the atmosphere, resulting in climate change. On a global scale, there's an amendment to the Montreal Protocol called the Kigali Amendment, and that is a phase down of HFCs on a global basis. It's not a phase out like it was with the ozone depleting potential products. Currently, the United States has not ratified the Kigali Amendment, and so what we're seeing and have seen over the past few years is that with the lack of federal oversight, many states are creating their own regulations to phase down HFCs. And that's specifically what is happening in California. So really what we're going to talk about today is these existing supermarket installations of greater than 50 pounds and the requirements around greenhouse gas potential reduction and GWP reduction by 2030. Very briefly, just going to touch on some definitions that we're going to be using and some vernacular and terms that we'll be tossing around today in the webinar. The first is the R3 database. That's the refrigerant registration and reporting system that is used in California. So if you are a retail food end user in California and you have systems with greater than 50 pounds of refrigerant, you are already registered, you report, and you use that system to, of course, pay payments e-payments as well. Global warming potential, I mentioned that earlier. GWP for California, the AR4 values are what are used for compliance and tracking. And again, each individual refrigerant has its own global warming potential. Greenhouse gas, or GHG, that's essentially a term that subscribes to many different gases, of which hydrofluorocarbons, HCFCs, and other related fluorinated gases fall into that category. There are a couple different calculations that we're going to talk about when we share some of the calculator tool. The first one is greenhouse gas potential, or GHG little p. It's essentially a sum of the charge size times the GWP. So it's a multiplied factor. And then weighted average GWP is just that. It's the greenhouse gas potential divided by the summation of the charge. And these are numbers that are part of the compliance plan for existing installed retail food facilities in California. Just a little bit on the background. This process has been going on for several years. It's not new. As early as 2017, CARB had announced the timeline for the new rulemaking. And during the past several years, there have been many opportunities and many stakeholder engagement processes that have happened along the way. Back in late 2019, early 2020, CARB, along with the NASRC and a group of different supermarket chains, participated in establishing some compliance pathways that both provided flexibility to the retail food end users and also met the requirements that CARB has in place for greenhouse gas reductions. So essentially what we're going to share is the stationary refrigeration requirements. So there's really two. There's a 150 GWP limit for new or remodeled facilities. But for the purpose of today's discussion, we're going to be talking about GWP requirements for the existing facilities in retail food. So again, for those facilities that have systems with greater than 50 pounds, there are company-wide reduction targets in place for supermarket and grocery stores that need to be met by 2030. This results in reduced emissions by either reducing the GWP of the refrigerant itself and or reducing the refrigerant charge size. The plan allows end users the flexibility to scenario plan and become compliant over the course of 8 to 10 years. So it does have flexibility for the retail end users as well. And in addition to that, it just provides the sector for, prepares the sector for HFC phase downs. So I mentioned earlier in the call that the U.S. has currently not ratified Kigali. However, in December of 2020, the U.S. AIM Act was signed into law, and that will authorize the EPA to regulate HFCs on a federal level. So while you may not have a footprint in California, if you are a food retailer and you're in other parts of the country, I think some of the things we're going to share today will be helpful for you to also scenario plan and look at reducing your greenhouse gas potential and your average weighted GWP. So this is really the requirement in a nutshell. I like this chart. CARB shared this with in one of their stakeholder meetings over the course of the summer. The wording itself is also in the regulatory text, but I think this is just a good overview of what the regulations require. So again, for systems with 50 pounds or more, companies owning or operating 20 or more retail food facilities and or national supermarket chains operating in California. There's really two steps here. The first is that by January 1st of 2026, the weighted average GWP needs to be less than 2,500, or the greenhouse gas potential needs to be reduced by equal or greater than 25% below the 2019 levels. By 2030, if you fall into this bucket, the weighted average GWP needs to be less than 1,400, or the greenhouse gas potential reduction needs to be equal to or greater than 55% below the 2019 levels. For companies owning or operating fewer than 20 facilities, you still have that same 2030 date. Again, the weighted average GWP, less than 1,400, or the greenhouse gas potential reduction of 55% or more below the 2019 levels. So again, the baseline is 2019 here. So just to kind of point out what that means, so some of the common refrigerants that are used in supermarkets today are 404 and 507. Those are very high capacity, very efficient refrigerants used in a low temp and medium temp refrigeration applications, but they're very high global warmers. They're hovering right around 4,000 plus or minus a couple hundred points. You also have R22 and R22-like refrigerants. 407A is an example, 407F, and these are all 2,000 plus or minus a couple hundred points. But you can see the red line here is that 1,400. Again, that's the goal for a weighted average GWP below 1,400 by 2030. And all of these refrigerants are above that threshold. There are refrigerants that are available to be used as retrofit or gas exchanges that can be used to replace these high GWP refrigerants, 449, 448. Those fall below 1,400 and are an ideal retrofit solution in a path towards compliance with requirements in California. All right, so I've got the first one of just two poll questions that we have. I'd like folks on the line, if you're in California or if you aren't in California, you can still comment here, but want to know which refrigerant is most commonly used in your retail installations. So R22, 404A, if you're using 507A, you can click 404A as well. 407A, 448, 449, if you're using primarily hydrocarbons or if you're using CO2. So I'll give everyone a moment and I'll just pause to give folks a chance to select their refrigerant. All right, I'm going to jump over. Okay, very good. Thank you for that input. So it looks like there's a limited amount of 22. Again, that's an ozone depleter with no longer being produced. So that's excellent to see the number here being so low. 404A, again, very high GWP refrigerant, hovering above 4,000. We see some 407A, which was often used in 22 retrofits over the course of the years. And actually, 407A has a higher GWP than 22. And then we start to see some of the 448s and 449s, which again are below that 1,400 threshold, and as well some CO2 here. So thank you for that information. And I think, Andrew, that dovetails us very well into your portion. Andrew's going to talk about refrigerant selection and HFOs for retrofit.
Great. Thank you, Christina. So moving forward, like Christina mentioned, we're going to first talk about refrigerant selection and HFOs in refrigeration, and then we're going to go over some case histories, and I will walk you through one of the tools that we developed to help end users with scenario planning for the 2030 CARB regulation. So when you look at the history of refrigerants, it's actually been a very long and interesting history to follow, where, I mean, some of the very first refrigerants that were ever used were industrial chemicals. And then around the 1930s, that's when really CFCs started to come into play. But due to the high ozone depletion potential of the CFCs, in conjunction with their higher GWPs, they were low-hanging fruit for phase out. And that led to the introduction of things like HCFCs and HFCs. And we as a refrigerant industry have been used to working with these products for most of our our entire professional careers. But as we look forward and see some of the regulations that are coming into play, this is an industry that is really on the brink of big change. And with that change is coming a new refrigerant classification. We're actually seeing in the today and tomorrow category, we're seeing both the industrial chemicals, some of which were the very first refrigerants that were used, come back. And then we're also seeing HFO and HFO blends play a very large role, especially in the existing installed base, as a way for refrigerant or end users to get to really no ozone depletion potential and very low global warming potentials to be regulatory compliant. Generally, when we make refrigerant selections or we're doing refrigerant evaluations, you really need to make sure that that refrigerant for the future balances not only performance, but it's also got to have proper safety, sustainability, and total cost of ownership. And really the combination of those four key metrics are really what's going to make a successful refrigerant for your installed base. Really one of the refrigerants that's going to play a large part in becoming compliant with the California regulations is products like 449A. Another one that is also used is 448A. Generally, they were both invented around the same time. And while I'm going to talk specifically about 449A, you really can approach it logically as the same thing as 404A and 507. They're both very similar performing refrigerants. It's just they have slightly different compositions. But anyway, so 449A was developed as a replacement for both 404A and R22 for commercial refrigeration, more specifically low temp and medium temp refrigeration. And there's trade-offs for each one of the retrofits, which we will go over. But generally, we have seen, even prior to California making the regulations, we have seen a lot of success using this product in retrofit scenarios. And where this product specifically is very, very important is its GWP being below 1400 will provide end users a way to get to below 1400 for their entire store footprint by 2030. Some other benefits, really, I think the two biggest benefits of a product like 449A are the energy consumption, especially compared to 404A. And also it has the ASHRAE A1 safety rating. So if you have a technician that was used to using A1 refrigerants, which if they've worked with R22 or 404A, they are used to working with them, 449A enables them to continue to use a product that has the same safety classification that they're used to working with. So when talking about retrofits, and when we have conversations with retailers or contractors, and really anybody that's interested in evaluating an alternative refrigerant, in a retrofit scenario, my main and primary goal in evaluations is to keep that existing equipment running. We don't really want to try to replace all the equipment because that's going to end up being costly. It's going to take time. And I mean, when you're talking about 2030 being only 9 years away, really a retrofit product needs to be quick and efficient. And the best way to do that is really to use a product that is going to be compatible with much of the existing equipment. You also want it to be simple and easy to service. Really, when you get that call at 3 in the morning that you're not getting cooling, you need to make sure that what you're working with can be serviceable. Long-term compliance is another big one. In the U.S. specifically, I personally believe for the past few years we've been in really a regulatory gray area where we really haven't had a good sense of where things are going to shake out. And things like the California ruling coming into effect, which really put a number that we can target to of 1400, really helps create a better sense of security that you're making the right decisions for your equipment. As far as the refrigerant criteria, safety of the system is paramount, right? So for any retrofit scenario, you're going to be looking at taking a A1 refrigerant and retrofitting it with another A1 refrigerant. And parallel to that, you really need an acceptable performance match. So really we want to keep the existing equipment running, but when we're doing engineering evaluations of supermarket systems, really the other thing that we absolutely always want is no surprises, right? So before any retrofit, we always make sure that whatever incumbent refrigerant you're using, the refrigerant that you're going to replace it with will be an acceptable performance match. And by performance, you're really talking about things like capacity, energy efficiency, low side, high side pressures, discharge temperature, really even optimizing a refrigerant with temperature glide to make sure you're getting the proper performance. All those different things play a role in making sure that your retrofit is going to be successful. And then compatibility with existing components and material is another big one, where if you're looking at the two kind of general buckets that I put retrofits in, you have the R22 retrofits, and then you have the R404A retrofits. And really, when evaluating a product for an end use, these are kind of the 6 different metrics that I will look at first to determine really what's needed to be a successful retrofit. So lubricants and elastomeric seals are really the 2 big ones that you got to focus on. If you have R22 or any chlorine-containing blend, that really the lubricant needs to be changed to POE oil. Typically, we recommend 2 to 3 oil changes prior to retrofitting to another refrigerant to make sure you're getting all of that residual mineral oil out of the system, and then changing the critical elastomeric seals. Any elastomeric seal that's been exposed to a chlorinated refrigerant for an extended period of time tends to not perform as well when retrofitted to a non-chlorinated refrigerant. So you can use the same type of seal, but it's generally recommended to replace it prior to retrofit. Expansion valves for R22 retrofits, really they are generally pretty compatible with the products like 448 and 449. You might have to do some adjustments post retrofit, but you don't have to worry about changing the power elements or anything like that. Filter dryers, that's standard practice for either R22 or 404A retrofits. You want to make sure you're changing those dryers out. 449A or 448A, really anything that you would retrofit to out of R22 is going to have a lower discharge temperature than 22, which is great for the compressors. And also for low temp equipment, generally you wouldn't have to worry about adding any kind of discharge temperature mitigation because it would already be there. For 404A retrofits, really you don't have to worry about things like the lubricant or the elastomeric seals, which is nice. But the one thing I would stress, especially in a state like California that's going to have to be looking at doing a lot of 404A retrofits in the future, the expansion valves will need adjustment post retrofit, whether that be fully closed or not fully, but really turning back those valves and closing them to increase the superheat. Also, it can be recommended in most instances to change the power element from an R404A type element to an R22 type element. For R404A low temperature compressors, typically you're going to want to review the guidelines from the compressor manufacturer to see if some kind of discharge temperature mitigation is recommended if it's not already on the 404A compressor. So moving forward, we did have a quick case history here. So this was a retrofit that was done a few years ago now, where it was a 404A store, design store, and they didn't want to go. Okay. It was a 404A design store that they were looking at doing a retrofit from the 404A to 449A and really trying to quantify what the changes were from using one refrigerant over the other. So post retrofit, they saw an 8 to 9% energy benefit from using 449A in a 404A design system. And that's really another big piece of it, where you have the direct global warming potential emissions from just the GWP of a refrigerant, but you can also get reductions from your indirect carbon emissions by lowering your electricity consumption from moving to some of these HFO blends. In this instance, no changes to the equipment, piping, lubricant, or seals and gaskets. Again, since it was a 404A one, you do not have to worry about changing the lubricant or gaskets. Adjusted the TXVs for optimized performance. I really can't stress that enough when looking at 404A retrofits. That's going to be, I would say, the biggest time hurdle, is really lining in that superheat post retrofit to make sure you're getting the optimized performance. But overall, once your system is dialed in, we would expect products like 449A or 448A to meet the cooling demand, and they will continue to operate stably. So moving forward, when we were first made aware of what California was thinking for their regulation, one of the things I thought of was, especially traveling to a lot of supermarkets, is you can have a lot of chains that have a number of different refrigerants in their systems. And looking at those different refrigerants that can be used, retrofitting them can change how many or what your weighted average GWP is going to be, or how large the carbon emissions are going to be, or the carbon emission savings are going to be. Also adding not-in-kind technology in there as well. I'm sure there's some end users that are wondering, should I just replace all of my 404A to CO2 and see what that would do to my weighted average GWP or your greenhouse gas potential, and really trying to understand if that is going to be more cost effective than retrofitting. So we're going to walk through kind of a made up supermarket chain here, and I'm going to include screenshots from the tool. Towards the end of the webinar, we will provide a link to the tool so you can play with it on your own. But we really wanted to make sure on this webinar that we showed you some of the functionality of the tool prior to introducing it. So in this case, I just created a supermarket chain, the Fresh Food Mart, that had 6 different stores with 7 different refrigerants. So they had everything from 404A to R22. I even put a CO2 store in there. And this is a prime example of a supermarket that you would see really anywhere, where you have a bunch of different refrigerants, and really what is the best way to hit that 1400 number given this refrigerant platform. So on the tool, really the first thing you're going to see is inputting the existing store footprint baseline. And what this will do is you can take any refrigerant that you have in your store. We tried to do essentially I would say the 80-20 view of the ones that you would typically see, things like 22, 134A, 404A, 407A's on there, 448, 449A, CO2, and make them just a single select option. But you will also note here there is a plus button. And with the plus button, you can actually input any refrigerant you want, and you can manually input the GWP value there. When you go over the plus button, you would also see that we included a list of the CARB AR4 GWP values for, there must be 50 or 60 different refrigerants that are on there. So any refrigerant that you want to input to your existing store baseline can be inputted through this tool. And once you input your system, towards the bottom of the calculator, you will see a bunch of different summary tables. The first one will show you your baseline weighted average GWP and your baseline greenhouse gas potential. The next box will show you what the targets would be for your greenhouse gas potential and weighted average GWP. The weighted average GWP target for California specifically is always going to be 1,400, but the greenhouse gas potential is going to be calculated to be a 55% reduction based on whatever the baseline is. And then the third box will show you, based on what you inputted into the tool, it'll show you what your current GWP is and what your current greenhouse gas potential is. And you'll see later, as we kind of look through different scenarios, once one of those meets the target, it'll turn green, and you will know that you have the right type of retrofits to remodels to really become compliant based on the California regulation. Also to the right here, you will see a breakdown tab where it'll show you your initial and your final charge for each one of the refrigerants that you input into the baseline. So in this case, they're all equal to each other because we didn't start doing any of the retrofits. But as you put retrofits or remove refrigerants from your portfolio, it would continue to populate in the refrigerant breakdown tab. So when planning for 2030, there's really 6 things that we put into the tool, and we do believe that this will get you most of the way there for really the options that you will need to become compliant in California. The first one is reduced charge. So you can use the tool. Let's say you had 1,000 pounds of 404A and you select reduced charge as your compliance method, then you can select how much you want to reduce that charge of 404A, and the calculation will continue to populate for whatever number you put in. So if you have 1,000 pounds of 404A, reduce charge by 500 pounds, the calculation will continue to be done with 500 pounds of 404A. Then we put 3 different retrofit options there. So retrofits to 448A or 449A, you can use those and you can do a 1-for-1 swap if you wanted. So if you had, again, 1,000 pounds of 404A and you did a retrofit to 449A of 1,000 pounds, the tool will do the calculation so that your GWP will change from 1,000 pounds of 404A to 1,000 pounds of 449A. We also put an option in there to retrofit to 513A. So 513A is a lower GWP 134A like fluid. It's in there, and really the one thing that's important to note is if you have a 404A system or a 402A system or an R22 system and you select retrofit to 513A, you just need to be mindful that that isn't necessarily a retrofit in the sense that you can use any of the existing equipment. Now, if you have 134A like equipment, or there's a number of 134A service blends out there, such as 401A, 409A, those R513A could be a great way to really lower your GWP because it has an AR4 GWP of around 600. We did include a remodel to CO2 on there as well. So if you wanted to take a store that was near the end of its life or the useful life of the equipment, it just really wasn't worth retrofitting, and you wanted to put something in there with a GWP of 1, CO2 is there to do that. And the calculation will continue to populate where it'll take the 1,000 pounds of 404A, for example, and remodel that to CO2 with the GWP of 1. And you can play with that to see, I don't know, maybe it makes sense to do, if you have a number of stores, doing one CO2 one, getting that really strong GWP reduction and then retrofitting the rest of the stores. I mean, the part of this tool is to help you guys try to answer those type of questions. And then there's also a no change option on there as well. So no change means exactly what it says, where everything is going to stay as is. So I wanted to show you kind of in the tool how that looks, where you'll see once you're in the tool for scenario planning, scenarios and options, it'll segment it by every refrigerant, and then for each refrigerant, you will have the option to either reduce charge, retrofit to 448A, retrofit to 449A, retrofit to 513A, remodel to CO2, or not do any change at all. And then as we were developing the tool, we didn't really want to keep scrolling back and forth and trying to answer like how much refrigerant did I have in the one store for 404A versus the other one. And so when you select a store that you want to do your retrofit in, or really any kind of change, it'll show you how many pounds you inputted for each store. So for R22, for example, if you had, if you retrofitted to 449A in Long Beach for 3,000 pounds, you could put 3,000 pounds there, where retrofitting to 449A in San Clemente, you could do 1,000 and 1,000 and then reduce charge. That'll work. Like, let's say you just wanted to get rid of that R22 system, you could reduce that charge of 500 pounds, and the calculation will continue to track your total refrigerant output for that. One of the things that I was thinking of as we were developing this is that each option will impact the GHGP and the weighted average GWP differently. So for simplicity of this example, I assumed a 1-for-1 swap where if you had 1,000 pounds of 404A, you would have 1,000 pounds of 449A. But sometimes that's not necessarily the case. And one of the things that you can do in the tool is, let's say you had 1,000 pounds of 404A and you only needed 800 pounds of 449A. So in that case, you can use the tool to do a retrofit to 449A of 800 pounds, and then you would reduce the charge of 404A for the other 200 pounds to balance out the total 404A management for that specific store. So you can see here, again, as you're playing with the different options in the tool, you will see that the results tab will continue to update itself for what the current weighted average GWP and the calculated greenhouse gas potential are. And as you go through those different scenarios, you can really try to make sense of what's the best use of my time, my money, really, and my sustainability goals to reach the compliance for the 2030 CARB goal. And as Christina mentioned before, we're in a world where the regulatory climate is starting to become a little clearer. The U.S. AIM Act was signed into law, so this is a tool that will have use outside of just California as well. It really can be a great way for an end user to really track essentially their refrigerant mass balance and try to determine the best way to optimize their GWP for the installed base given the regulations in their territory. So the one thing that we thought was really important when making this tool was that there was a download as Excel button, and we wanted this to be there for two reasons. One of them being that we included the 6 options of the 3 different retrofits, remodel to CO2, no change, and reduced charge, but there's certainly many different other options out there. So the download as Excel tool will give you a way to really work with your installed base, and you can use the numbers and the logic in the calculations to try many different things. I'm certainly willing to bet that 5 years from now, the refrigerants that are out there today, there could be new ones out there. I mean, we're on the cusp of A2Ls being introduced into the marketplace. A lot of the technology around things like hydrocarbons is increasing as well. So there's definitely other options beyond what was included in the tool, but the Excel sheet will give you a way to really continue to track what is done in the tool and give you a way to do calculations for other refrigerants that may not be included in the tool. And then, it is very evergreen. If there is something that you think we really missed or should have included, we can definitely work to try to get it included in the tool moving forward. So here's a link to the tool. I think these slides can be provided, and I believe the link is live now. So, as I really welcome and recommend anybody that is interested in trying to find the best way to do their refrigerant management planning for California specifically, or even really anywhere. If there's any kind of refrigerant management you have to do, I strongly recommend using a tool like this to really help you out and make your lives a little easier. So I think we have a second poll question here, and it says, would you find the GWP calculator tool something that would be helpful for your company in planning a path to compliance for your installations in California? And there's two options here. There's very helpful or somewhat helpful. So we'll give you a minute here, and then we'll push through the results.
Thank you, Andrew. I think that was a very thorough, excellent explanation. Again, to the points that Andrew was making, one of the other advantages from a planning perspective and a scenario planning perspective that the calculator tool will help with is, as an end user, you can create various different scenarios over the course of the compliance timeline, and use those also to kind of think in terms of your budgeting and your resource, whether it's scheduling mechanical contractors or providing budgetary information to your business as well. So I'm going to click forward. And so the feedback we're getting would be very helpful, and some are thinking it would be somewhat helpful. So thank you for that feedback. We do encourage you to play with the tool. When I close out the webinar, we have contact information as well. We're here to help. We have engineers that can help walk through the tool while you're using it, and also, of course, talk about retrofits. So just a couple things I wanted to highlight before we get to the Q&A portion of the webinar. We have some related tools that are available on our website. So in addition to the calculator, we have a one-page summary that captures all of the regulations pertaining to food retail in California. So it includes the SNAP 20 and SNAP 21 requirements, as well as the existing facilities with the GWP and weighted GWP and greenhouse gas potential reduction. We have a lot of case histories available on our website as well. I know Andrew walked through retrofits at a high level, but we have detailed retrofit guidelines available as well on our website. So for those of you who like videos, we have a series of YouTube videos hosted by Dr. Chuck Allgood, and these have been pushed out weekly in 2020, I lost a year. But there is one specific related to California regulations as well. So if you have colleagues maybe who weren't able to attend today, or just want to listen to a shorter version of the California regulations, there's a brief 7 to 8 minute video that Chuck has created, and it's available on YouTube. So again, just at a high level, and we'll jump into questions and answers. I think if there are some takeaways that we'd like folks on the line. One is California refrigerant regulations do impact your business decisions. If you have 22, didn't look like we had a lot out there, but if you have 404, 507, start putting a plan together regarding those conversions. Refrigerant retrofits are a very cost-effective way to achieve regulatory compliance in California. Again, we have a new calculator tool that can help scenario plan towards those 2030 goals. And ultimately, we want to engage with your operations, engineering, and facility managers, whether it's helping with the tool or it's helping with training around retrofits. We're available and eager to help with that. All right, so at this point, I think we'll pause and do some Q&As. Michael, I think you have.
Yeah. Questions have been coming in, and let's get right down to those. Actually, I have a question here for Chuck. In the example using the calculator tool, you included CO2 as an option. Could a retailer become compliant simply by doing gas conversions to lower GWP HFO blends?
Hi, everyone. This is Chuck Allgood. Didn't get a chance to speak yet, but I'm glad to be here, and thanks for tuning in, everyone. Yeah, so I think as Andrew mentioned in the tool, we wanted to give all the options that people could use in going through, because the regulations are really what I think CARB called a fleet standard. It really is your entire footprint. So just for clarity, if you're building a new store, that's going to have to be included in these calculations. If you're shutting down or decommissioning a store, that will come off. If you buy a store, sell a store, all those changes are going to be factored into these calculations. So the second point, I think Andrew also mentioned, yeah, CO2 can be a pathway. It's not a retrofit solution. That is, you can't put CO2, I think most people know this, into an existing equipment. So it really would be a full gutting of the refrigeration system. Compressors, condensers, piping, cases would all have to be torn out and replaced with new. But to answer the question, yes, you can get there, and that's what the tool will help you figure out by doing these gas conversions from the higher GWP HFCs to the lower GWP HFO blends. And you know, how much of it you have to do depends a lot on where you start, whether you're 404 heavy or 22 heavy, or you have a lot of other things in there. The calculator will help you figure all that out. But the answer to the question is yes.
And following up on that, Chuck, how does the cost of a gas conversion compare to installation of a new system using CO2?
Yeah, that's a good question. Obviously, we can look at the GWPs and where it gets you. The second thing to really look at is how much does it cost to do that. Again, the gas conversions or retrofits, as we call them, it depends a little bit on how involved you get them. You know, whether you do need to change the oil or not, change any valves, elastomeric seals. But in general, you know, back of the envelope calculations, I would have put a stake in the ground, you know, 80,000 to 100,000 to do those type of conversions from something like 22 or 404A to 449. And, you know, a brand new a state-of-the-art transcritical CO2 is probably, you know, roughly around $1 million. So about a 10x factor in cost between those two options, I would say, plus or minus.
Okay. I have a question in for Christina. Is the retailer data entered into the calculator private, or does Chemours have access to that data?
Okay, great question. Thank you for that question. Chemours does not have access to the data. We are not collecting or harvesting the data. It's a web-based tool. So when a retailer logs into the link and inputs their data, they can download it to their own Excel spreadsheet. And again, that's their private information. We don't retain any of it, nor do we have access to the inputs that a retailer has put into the calculator.
Andrew, here's one for you. Do I need to replace gaskets when converting to R44.8A or R44.9A?
So it depends on the type of retrofit you're doing. If you're doing a retrofit from R22 or any R22 or HCFC containing blend, you would want to replace the gaskets. As far as like when to do it, we've seen people do it a day or two before the retrofit, and we've seen people do it the night of. That's just really from personal experience of sitting overnight at retrofits. You know, I don't think I could really say which one works better, but you know, we haven't, as long as those gaskets are getting changed close to the retrofit, I believe we're not really seeing large amounts of leaks or anything like that.
Here's a good question. What's the consequence if you don't meet the dates, the required dates? Any of you?
That's a good question. I don't even know on any of the. Go ahead.
No, I would refer that question to CARB, really. And
I think so too.
I haven't heard any of the kind of enforcement side of things.
Here is Chemours able to help me create a plan for my tank?
Absolutely. We have several different technical resources. Andrew and Chuck, of course, are just two of them. We also have an account manager that's located in California. So anybody, any end user or retailer that wants some help in terms of creating a strategy, we're absolutely here to assist with that process.
Can you mix 448 and 449?
No, mixing refrigerants is not a recommended practice. We see it happen. I mean, they're very similar products, but per EPA Section 608 guidelines, mixing refrigerants is not recommended.
Are there any indications that other states are going to follow suit? Their own versions of CARB.
Yeah, so
there are a
CARB
number
is.
Go
ahead.
Chris.
Sorry.
I was going to say there are a number of other states who have signaled and started down the path to regulate HFCs. California is ahead by far. And now with the recent federal developments, I'm not sure what that is going to do to the state level thing. I don't know what you want to add, Christina. Go ahead, please.
Yeah, I was going to say there are a number of climate alliance states where either the governor or other organizations within the state have committed to HFC reductions. But to Chuck's point, none of them have a plan as robust and detailed as California. Some of those actions may slow down as a result of the AMAC being signed into law, waiting for some federal oversight, but it may be too soon to tell. There are other states that have adopted the SNAP 20 and 21 rules as well. And we have that information on our website. So if you happen to be in a state and you want to know, we have a broader regulatory document that includes all the states that have adopted SNAP 20 and SNAP 21.
Do the regulations also affect the convenience stores and restaurants in the state? It's not just supermarkets, right?
So it's systems that have charge sizes of 50 pounds or greater, which typically falls into retail food supermarkets. The restaurants and convenience stores in California are typically going to be more falling under the SNAP rules, which essentially eliminates the use of 404, 507, and various other refrigerants and new condensing units, that type of thing. Chuck, would you like to add any comments to that?
Yeah, I agree. Retail food, I guess, is the key regulatory language. But then under that, it's the kind of 50-pound, which I think would exclude most convenience stores just because they don't typically have those big systems. But if they did, I think then a convenience store, if they had a system with over 50 pounds, would have to comply.
Here's a question. Just curious if it's possible to achieve the needed % reduction without reaching the 1400 GWP weighted average. If so, could the tool be used to help understand this?
So can you repeat the first part of that question again?
Sure. Just curious if it's possible to achieve the needed % reduction without reaching the 1400 GWP weighted average.
Yes, it doesn't matter which way you comply, either by the weighted average or by the % reduction. And I think that's one of the great advantages of the tool, because where you end up in a large part depends on where you start. Like I said, so if you're starting it with a lot of R22, which is about 2,000 GWP. It's a lot bigger percentage reduction because you're starting from a lower number. If you're starting some high, about 4,404, the percentage you can get down goes a little quicker. So which one gets triggered first really depends on the details of the specific refrigerant you have and the choices you make in converting and doing the retrofit. So yeah, use the tool. You model it all out, and it should be very straightforward.
Okay, good. Here's an attendee who asks, he's read where the new equipment is required to be under a 150 GWP refrigerant. Is that true?
New equipment with a charge size of 50 pounds or greater is a 150 GWP limit.
Okay. And then a couple of questions on the tool. Does the tool contain info on A2Ls, and any thoughts on when A2Ls may be okay for use in walk-ins and or display cases?
Andrew, you want to take that?
Sure. Currently, as far as refrigerant management options, the only retrofits that we included were 449A, 448A, and 513A. The primary reason being we're, I think, all still anxiously waiting for the codes and standards to be updated to get a sense of how and where A2Ls can be used. But I can almost guarantee you that once we have the clarity on really where A2Ls can best be used, they will likely be added to the tool.
And in the meantime, Andrew, if they wanted to play with an A2L scenario, they could input that as its own individual refrigerant. Is that correct?
That's correct. And then also that, again, that's why we included the download as Excel part of it, where let's say you had a store like 404A supermarkets and you wanted to see what an A2L would do to it. You can see the logic of how the calculations are done in Excel and just substitute the GWP of an A2L for one of the other ones and see how it would impact it.
We have a question from our friends at Albertsons and Bonds. Is the planning tool free?
It is free. Yes, it's free. Everyone who's on the webinar will get an email with the link, but it is free, no charge.
Great. Jeff from Brookshire Grocery asks, how long prior to retrofit Merck seals be replaced without harming the new seals?
I'd say there isn't really a hard number or day prior to retrofit for that. Again, we've seen people change the seals maybe the night before the retrofit, and we've seen people change the seals the night of the retrofit. Typically, you want to do it pretty close to when the retrofit's happening, but I don't think there's a hard and fast number for when it has to be done by.
Got it. Okay. We're just about out of time, but some of the questions that have come in that haven't been answered on this call will be going to Chemours, and they'll be able to reach out and respond to those members of the audience. I just wanted to once again give thanks to the folks at Chemours for sharing their time today. Chuck, Andrew, Christina, excellent job. Thank you for being with us today.
Thank you.
Yeah, thank you.
Yeah, thank you as well. I've got my contact information available for anybody, our tech-to-tech line, and we appreciate your time. And we certainly, as general consumers in the U.S., appreciate all the hard work and effort that supermarkets have made this year to keep our supply chains stocked and our friends and families and community supplied. So thank you again.
That's great. Thanks very much, everybody. Have a great day.
Thank you.
Thank you.